All right, good afternoon. Online students, can you hear me? Can you see the screen?
Yes, sir.
Yes, sir. All right,
Yes, sir.
good. All right. Okay, guys, remember, noise and internet don't work very well together. All right? So let's just have a very efficient session. We'll get through these questions. I think I want to do 4 of the questions today. Is revision again of the topics that we started since September. We're starting over. Quadratics, functions, algebra, factorization, inequality, variation. These are all the topics that we did. And then I'm going to go up to coordinate geometry, at least those 4. And I might decide to start with linear programming tomorrow. All right, so linear programming tomorrow, matrices transformation. Then over on page 3, we're looking to do this vectors question here. And I might throw in another vectors question, another transformation question. Maybe a tricks question to make it 4 questions tomorrow. And just do a look at 1 tricks question tomorrow. So I'll find a trick question and I'll send it in the group to Dubai tomorrow. And we deal with it tomorrow. I'll send it in the group later. If I don't send it, send me a message. If I don't send it by 9 p.m. tonight, send me a message or remind me to send a tricks question. All right, let me find a nice tricks question for you to revise some tricks. All right, we're gonna be doing after we finish this paper tomorrow. We're gonna be working from past papers, just revising from past papers. So I just send out the past paper, tell you which of the questions to do on it. You should be able to do more than half of the paper now. You should be able to do maybe 2 questions from the 3 questions in section 2, or at least 2.5 of them. And a good number of questions in section 1. Also, I'll be sending you multiple choice papers to practice. And as you do those papers, you need to do them. A lot of persons not doing them. You need to do the multiple choice paper. Let's not take multiple choice for granted. Multiple choice is like 30% of the exam. And we want the full 30% of the multiple choice in the exam. We want the full 30%. So remember, the exam is 20% SBA. You want the full 20% on the SBA. 30% multiple choice. You want the full 30%. That's 50% already. And then now we have our way with the other 50% on paper 2. That is how we get the grade 1s. All right. So let us not take this multiple choice thing for granted. We have to go hard at the multiple choice because we want the full 30%. So I'm giving you those multiple choice papers to do from now. Start working on them, start practicing them. When I send you the answers or I send you video solutions, and you find that you get a question wrong, you need to work it over. Multiple choice paper in this program is a 100% program we operate in this class. Meaning, if I give you a multiple choice paper to do, any question that you get wrong, you have to redo it. 100% system will work because the majority of questions are repeated. If they're not repeated exactly, they're repeated with minor changes, and we need to understand the question, not know the answers. We need to understand what we're doing. So when they make those minor changes to the question, we still know what to do. All right. So any question you get wrong, you need to redo it. Because there's a great chance that the very same question you get wrong can come back on the exam paper or one like it. So we need to ensure that we understand all those questions. All right, I was starting from now. I want to get 30 out of 30. I want to get full marks, 60 out of 60 on the multiple choice. And on a bad day, 58 out of 60. Telling you from now, that is the target grade for the multiple choice. No less than 58 in the real exam. And so we have to start getting 58 out of 60 consistently from now, so that we can get 58 or more on the real exam. All right, no less than 58. All right, so start taking it serious for me, please. All right, let's go. So this question starts out, is a quadratics, but the first part of it is to factorize those two. So that's a quadratic to factorize, and then this is a factorization by parts. All right? Nice question. So part 1 gives us this 2p squared minus 7p. Make the pen a little darker. Hold on. Let's make this a little darker. All right, let's go again. All right. So it's 2p squared minus 7p plus 3 to factorize. Now, these are easy to factorize, you know. This one is in particular easy to factorize because the end values are prime values. The only factors of this 2 is 2 and 1. And the only factors of this 3 is 3 and 1. So those are the values going in the bracket. For sure. What you have to remember is that the far product and the near product must give you the middle term. And so this one is easy to do. You don't need to go through the process for this one. Because the only factors of the 2p squared is 2p and p. The only factors of the 3 is 1 and 3. So it's just a matter of where you place the values. I'm going to do it that way this time. We have to improve. We have to improve. So I'm going to write down the factors of this and show you how you can check if it is correct. So I'm going to factorize it quick and fast without going through the process.
Are you screen sharing, sir?
Huh?
Are you screen sharing?
Not sharing? Yes. You're not sharing?
Okay. Let me just reset. I'm not seeing this, sir. So I just asked.
Oh, good. Thanks for that. See it now?
No, sir, maybe
See it
just
now?
me. I just come off and come on back.
Sir, we are seniors.
But see it. Oh, okay. Right. All right. So, ready, let's go again. So the only factors of this 2p squared is 2p and p. And the only factors of this 3 is 1 and 3. So it's a matter of where you place the 1 and where you place the 3. All right? So let's say I make a mistake. Let's say I do it the wrong way and put the 1 here and the 3 here, which I know is wrong. This plus tells me that I need the sum of the far product and the near product to give me this middle term. The sum of the far product and the near product is going to be the middle term. Right now, the far product will be 2p and the near product will be 3p. When I add them, I'm getting 5p, but my middle term is actually 7p. It's actually negative 7p. So that means that these values are placed the wrong way. These two values are the wrong way around. I need to reverse them. So let me say, put the 3 this time here and the 1 there. So the far product is now 6p and the near product is now 1p. 6p and 1p is 7p. So you know that the values are now in the right, youngster. Don't let me get upset. Class just start. All right? So those are in the right place. Watch this now. This value, because it is a plus, it means that the two values in the bracket must be the same. The two values in the bracket must be the same. The two signs in the bracket must be the same sign. And this tell you what they are. They are both negative. So the two signs in the bracket are the same. That's what this plus also means. This tells you what they are. So both of them are negative. Watch over the video and listen what I said. Those are now the two factors. You can check it. The far product here is negative 6p and the near product here is negative 1p. Negative 6p and negative 1p gives you the middle term of negative 7p. So those are the two factors right there. I wanted to practice doing it the shortcut way, especially when the n values are prime. You don't need a long process when the n values are prime. But the only factors of the 2p squared, as I said, is 2p and p. And the only factors of this 3 is 1 and 3. It's just a matter of where you place them in a bracket. You have to place them in a way such that the far product and the near product gives you this middle term. All right? So those are the two factors. Quick and fast, nice and easy. Very good? Online, very good?
Yes, sir.
All right. The second one, this one, This was part 1. This is now part 2. It gives us 5p plus 5q plus p squared minus q squared. There's a combination one, combined one. The common factor in the first 2 terms is 5. I'm going to get p plus q in the bracket and factorize the 5. We must recognize that this is the difference of 2 squares. It becomes p minus q and p plus q. So you're going to get a second p plus q when you factorize this part. So it's a kind of a new unique one. So the factors of this one will be 5. Of these 2 will be 5. And you will get p plus q in the bracket. Then the factors of these 2 would be p minus q times p plus q, difference of 2 squares. And so this p plus q is now a common factor. And so you're putting these 2 together times a common factor. All right? And so it becomes this. It becomes 5, and then this, adding those, plus p minus q in one bracket times the p plus q right there. That is the answer. So that kind of unique one. So these, you pay attention to them and you put them in the special questions book. But okay with that? Very good?
Yes, sir.
All right. That is it. All right. Next question is asking us to just expand this thing and write the answer in descending powers of x, meaning like x cubed first, then x squared next, then x next, and so on. Descending powers. Start with the highest power of x, and you work your way down. So they want us to expand this thing. All right? So let's do it over here. So I have x plus 3 squared multiplied by x minus 4. So you must know we have to do this power first, right? Good? Order of operation, we have to work out what this is first. Do this power first. And so we're going to expand this first. Remember, the expansion of a perfect square is the first term squared, which is x squared, then twice the product of the 2. How do you do twice the product of the 2? You multiply the 2 things first, you will get 3x, and you double that to 6x. So the middle term is 6x. You do the second term squared here, which is a 9. And that is the result from expanding this perfect square. You multiply that now by x minus 4. Very good so far? Very good?
Yes, sir.
Next, what we're going to do next now, we're going to use this x squared to multiply each of these 2 things. They want to use this 6x to multiply each of these 2 things. They want to use this 9 to multiply each of those 2. All right? The x squared first times these 2. So the x squared times this is x cubed. Then the x squared times this minus 4 is minus 4x squared. Then this 6x times this x is plus 6x squared. Then this 6x times this minus 4 is negative 24x. Then it's time for the 9 now. The 9 times the x is 9x. And the 9 times the negative 4 is negative 36. They consolidate the values. This is the only x cubed term in there, so it stays x cubed. They added these 2 like terms, those square terms. It becomes negative 4x squared plus 6x squared, same as 6x squared minus 4x squared. So 6 minus 4 is 2. So you get plus 2x squared. Then these 2 is negative 24 plus 9. Same as 9 minus 24. How much is that? That's negative how much? 15. That's negative 15x. Correct? Agreed? It's like minus 25 plus 10. That's not right. That don't right. That don't look right to me. Yeah, it's right. It's right. It's right. Somebody tell me if it's right. 9 minus 24. And then we subtract
15, sir.
30.
9 minus,
Huh?
9 minus 24 is 15.
Yeah, 9 minus 24 is how much? How much is it?
15.
Okay, right. All right, good. So that is the result. Descending power. So the cube term first, then the square term, then the x term, and then the 36th, and that is it. But good?
Yes, sir.
That is it. That is the result. So finish this, finish that, finish that. Remember, any question I get wrong or I didn't do, we need to go and do it. All right, we'll come to part C now, which is a complete in the square question. Let's do it. Let's practice that one again. So it gives us this function, f of x is equal to 2x squared plus 4x minus 5. And it wants us to write it in this form. Yesterday, the question that we did, not yesterday, the day before yesterday, the question that we did was H and K. This time is A, B, and C. All right, so let's not confuse the A, B, and C in this with the A, B, and C and that. It's not the same. This is just the form that they want the expression to be in. They are just telling us to complete the square. Don't mind the A, B, and C. That's just the form they want the result to be in. So we're going to use our standard way, our normal way of doing it, which is to write it as A into x minus xt squared plus yt. So the xt is the x value at the turning point, yt is the y value at the turning point. All right? And what we need to do is calculate the xt and the yt. So the formula for the xt, remember, is negative b over 2a. What is the a and the b in here? They are the coefficients in the standard form of the quadratic up here. So let's write them out. So in this standard form, the a is a coefficient of the x squared here, which is a 2. So the a equals 2. The b is a coefficient of the x. Coefficient of x is this positive 4. And the c is a constant term, which is negative 5. So the a and the b are going to be using this formula. So this becomes equal to minus the b. The b is this 4. There's minus 4 over 2 times a. The a is 2. It's 2 times 2. That becomes negative 4 over 4, which is negative 1. Now, when the xt come out to be a whole number like that, you can find your yt value another way by substituting that xt value back in the original function to get your yt. So usually when you get whole numbers for your xt, you can just find the yt by substituting it back in the original function. Remember, xt, yt is a pair of x and y value at the same point on the function. All right, so you don't need to use the formula method to get the yt value, especially when your xt value is a whole number like that. All right, so we're going to write it this way this time. So yt becomes the f of minus 1. We'll put in minus 1 in this, which becomes 2 times minus 1 squared plus 4 times minus 1 minus 5. This minus 1 squared is a positive 1. 2 times 1 is 2. This 4 times negative 1 is a negative 4, and then subtracting this 5. This is 2 minus 9. 2 minus 9 is negative 7. So your yt is negative 7. I'm going to do it the formula way just to show that you're going to get the same answer. All right? Let's do it another way just to show that we'll get the same answer. We're going to say, or the yt, using the formula of the 4ac minus b squared divided by 4a, which will be 4 times a. The a is this 2 up here, times c, which is negative 5, minus the b now is 4, so subtracting 4 squared, all over 4a. The a is this 2. Let's simplify this. This will be 4 times 2. All right, this is 10. Negative 10 times 2 is negative 40. It will be negative 40. Minus, this will be 16. So subtracting 16. And dividing that by this 8. That will be negative 56 over 8. Because that's become negative 56. Negative 56 over 8 becomes negative 7. So you could get the same value using the yt. We see that in this case, because your xt is a whole number, a nice, quick, and easy way to find the yt, so substitute that xt value back into the original function and get the y value there. All right? So now that we know the xt and the yt value, our values, we can now write this function in this format. So this then becomes that f of x becomes equal to the a. The a is this 2 up here into x minus the xt value is a -1. So the minus becomes a +1. But I can appreciate that. And put on the square. And then you're adding yt. Yt is -7. So we're going to put -7 for the plus yt. And this, therefore, is a function after you complete the square. All right? That finishes that part. But I go to that online.
Sir.
All right. Part 2 wants the equation of the axis of symmetry right here. The axis of symmetry equation. Axis of symmetry. Is x equal whatever the x value is at the turning point. X value at the turning point. X equals the x value at the turning point, which is -1. So that equation is x equals -1. That is the answer for the x value at the turning point. For the axis of symmetry, which is the x equals x value at the turning point. X equals -1. That is the equation of the axis of symmetry. That vertical line that passes through the turning point. Then I want the coordinates of the minimum point next. Part 3 wants the coordinates of the minimum point. So the minimum point, which is the turning point, has coordinates xt, yt, xt, yt, which is equal to the xt is -1, the yt is -7. That's the coordinates of the turning point, as simple as that, xt, yt. All right, that finishes this part. And then the next part wants us to sketch a graph. And then on the graph, they want us to show the minimum point and the axis of symmetry. So this one did not want the roots. All right, so let's do the sketch. So -1, -7. Let's set it up like this. Y-axis, x-axis. All right, so we know it's going to be a smile shape because the square term on that quadratic function is positive. So it's going to have a smile shape with a minimum point. Then we know that it turns at this minimum point. It was -1, -7. It was a turning point right here. So where would this point be? This point would be somewhere in this quadrant where the x value is negative and the y value is negative. These are different color. So this turning point is going to be somewhere down here. -1, -7 is going to be somewhere down here. So we know that it turns somewhere down here. The next part is the y-axis intercept. Where does it cut the y-axis? It's cut the y-axis at the c value of -5. -5 is somewhere on this part of the y-axis. So it must turn in this quadrant and cross the y-axis somewhere down on that leg of the y-axis where the y value is negative. So you need to draw that, a smile that turns down here and crosses somewhere down here. So it's going to draw it like this. Let's try it again. That is it. So it turns down here and crosses down here. So this is the minimum point, which is -1, -7. And this is the y-axis intercept, which is 0, -5. 0, -5, but the c value is -5. So the y-axis intercept is always at the c value. That is it. And then I want us to put in the axis of symmetry, which is the vertical line passing through this turning point here. That's the axis of symmetry. And it is x equals the xt value at the turning point, which is the -1. And that is the sketch of the function right there. All right. So this is the sketch of f of x. That is it. Very good. Let's show the minimum point. on the axis of symmetry. But all right?
Yes, sir.
Online, you good? All right, beautiful. 1 down, 3 to go. Remember, if you didn't get it right, you need to go and do it. Do it again. I'm going to share the video in the group. You can look back at the video if necessary. All right? Very important that you do the work, guys. Very important. Let's look at the functions question now. Right here. Functions question next. All right. This gives us two functions. It says f of x is equal to 7x plus 4, and g of x is 1 over 2x. Let me set up a smaller. All right. First part wants g of 3. We're talking now. G of 3 means that we're going to put 3 in the g function right there. So first part, g of 3 coming inside the g function. So it becomes 1 over 2 times 3, which is 1 over 6. Next part wants f of negative 2. So I'm going to put negative 2 in the f function right there. So part 2, the f of negative 2 becomes 7 times negative 2. I put negative 2 with here, plus 4. That's negative 14 plus 4 becomes negative 10. So the answer there is negative 10. But 7 times 2 is 14, but the negative. The next part, we want f to the minus 1 of 11. F to the minus 1 of 11 can be found multiple ways. Okay, easy method, we'll find f to the minus 1 of x first and then plug the 11 in it. All right? I think that's the way most persons will do it, but I'll still do it another way and show you. So we're trying to find f to the minus 1 of 11. You know, to me, run out of the class and stop talking. Not talk, can't make me hear not talk. Let's do the f to the minus 1 of x first. So to do this, we're going to find f to the minus 1 of x first. And then we find f to the minus 1 of 11. That's the method we're going to use first. I'm going to show you another way to do it. Anyway, do it, you're going to have to do some transposition, right? All right, so we're going to start by saying f equals 7x plus 4 from this function. Just leave off the of x. I don't need to put it. I'll just leave that off for the time being. So this is the function. We're going to inverse it. So the f, which is range on the function, becomes domain on the inverse, which is represented with x equals 7 times x on the function becomes range. X on the function, which is domain, becomes range on the inverse. Range on the inverse is f to the minus 1. I put about that plus 4. You're trying to make this a subject. Easy. Transpose this 4, make it negative 4 on that side, and then divide under the 7. Easy as that. So this f to the minus 1 is going to become x minus the 4 minus this 4 divide under the 7 divided by 7. That is f to the minus 1. You can put in back of x though, f to the minus 1 of x. And then to find f to the minus 1 of 11, we'll substitute 11 in this now. So we can say therefore f to the minus 1 of 11 becomes 11 minus 4 over 7. I'll plug the 11 in there, right there. 11 minus 4 is what? 7? 7 over 7 is 1. So the answer is 1. Let's look at another way we could do it, which will involve some transposition anyway. All right? So this is it now. Trying to find f to the minus 1 of 11, right? So we're going to say, let f to the minus 1 of 11 be equal to some number n. We're trying to find what n is. When you find n, you have the answer. So if f to the minus 1 of 11 is equal to n, it means that 11 is equal to f of n. F of n. Then f of n, just when you plug n in the f function right there, that's f of n. So you really now solving 11 equals 7n plus 4. So this is the same thing. You're trying to make this n the subject. Subtract this, the 4, and divide under the 7. So the n would be equal to 11 minus 4 over 7. Sorry about that, guys. 11 minus 4 over the 7. I'm divided by the 7 right here. That works out to 1. So the n equals 1. Remember, the n is what we call f to the minus 1, right? F to the minus 1 is 11. Right? So therefore, f to the minus 1 of 11 is equal to 1, because the n is 1. All right? So either way, result is the same. But to go to that, I think most people would approach it this way. We'll find f to the minus 1 of x first, and then plug in the 11. All right, next part. Part B. Part B. Let's go. The part B gives us these two functions, h and k. So it is h of x equals 5x minus 2, and k of x equals 4 over x plus 1. All right? Then the first part wants us to find h of 0. So we're going to put 0 in the h function right here. H of 0 means I'll plug in 0 in the h function. It becomes 5 times 0 minus 2. That becomes 0 minus 2, which is negative 2. Because that's a 0. Next part wants k of 2. We're going to put 2 in the k function now. So the second part is k of 2. Putting 2 in here. So it becomes 4 over 2 plus 1. 2 plus 1 is 3. So this becomes 4 over 3. Done. Next part wants h to the minus 1 of x, which is the inverse of this function. Easy question. So for part 3, start by saying h equals 5x minus 2. Then we inverse it. The h becomes x. And the x, which is domain, becomes the range on the inverse function, h to the minus 1 minus 2. And we're trying to make this a subject. Transpose the 2, add it, and then divide under the 5. So it's the same transposition all the time, but it's linear functions. So it becomes x plus 2 over 5. That is h to the minus 1. Okay, I'm putting back the of x now. So this is right here, the answer. H to the minus 1 of x is equal to that. Next part says, find the value of x if h of k of x is equal to 1. All right, that's part 4. H of k of x is equal to 1. So to do this, all we have to do is form the h of k and equate it to 1. So the h of k is obtained by substituting the k function into the h function. Let's write them out again. So the h function, remember, is 5x minus 2, and the k function is 4 over x plus 1. This means that we're taking the entire k function and putting it into the h function where the x is. That's how we form the h of k into h. All right? So setting up this side by doing this substitution. So then this thing then becomes 5 bracket 4 over x plus 1 minus 2. It becomes h of k now is equal to 1. But I understand that?
Yes.
Understand that? Good. And you're
Yes,
solving this now. Solving this now for the x. Solving for the x under here. All right. So this negative 2 goes over and add to that to give me a 3 on the right side. And it's 5 times 4 makes it 20. So it becomes 20 over x plus 1 equals 3. They want to make this x a subject. I can take this x plus 1, multiply it up here, and take this 3 and divide it under. Or I can just multiply it with the 3 CMA. But I think it's easier to just write as 20 over 3 equals x plus 1. But can I say that?
Yes, sir.
Can I say
yes,
that?
sir. Yes, sir.
Good. And then make x a subject. Now, when I transpose the 1, becomes 20 over 3 minus 1 equals x. But this 1 is the same as 3 over 3. And put it beside it. It's the same as 3 over 3. So it really becomes 20 minus 3 over 3. And so the x is now equal to 17 over 3. And that is the answer right there. 17 over 3 is the x. But good? But all right?
Yes.
sir.
All right. 2 down, 2 to go. Yeah, question done. But all right. Can we do the additional
sir.
question today? And send 2 more in the group then. Yeah, we can do work up to the linear programming and send 2 more in the group. All right, so that one finished. Remember, any question you didn't do, you need to go and do it. And the question you got wrong, you need to redo it. All right, you have to do the questions. You have to do the questions. Watching me do the questions is not enough. Yes? This one, these steps. Right, so remember, I'm trying to make x a subject, right? So I want to get it out of the denominator. So I can multiply it up and then take the 3 and divide it under. And so I get x plus 1 equals 20 over 3. See that? Good. Another question? Very good? All right.
Okay.
All right. Next one. All right, so this one has 5 parts. Each part is a different question. Let's go. Each part is a different question. First part wants us to write these 2 fractions as a single fraction in lowest terms. Remember, those are algebraic fractions. But whether you're adding algebraic fractions or numeric fractions, you want them to be related, meaning you want the denominators to be the same. When the denominators are the same, you can just add the numerator and put by the common denominator, all right? So let's do it. All right. So I have x minus 2 over 3 plus x plus 1 over 4. Lowest common multiple of the 3 and the 4 is 12. So 1, 2 denominators to become 12. I want to adjust them. For this one, to have a denominator of 12, I need to multiply the numerator by 4 and the denominator by 4. So I can take this denominator and multiply it up here and down here. Then for this one, to have a denominator of 12, I need to multiply the numerator by 3 and the denominator by 3. So again, it's like I take the denominator and multiply it up here and down here. So I'm multiplying this fraction by 3 over 3. Then I consolidate the values, work them out. 4 times x is 4x. 4 times this negative 2 is negative 8. Over 4 times this 3 is 12. Plus, that's this plus. 3 times this x is 3x. 3 times this one is 3. Over 3 times this 4 is 12. So now that they have the same denominator, we can add the two numerators algebraically. So the final result is going to have a denominator of 12, and the 4x plus the 3x is 7x. The minus 8 and this 3 becomes negative 5. Negative 8 plus 3 is negative 5. Minus 5. That is the result right there. That's the answer. Done. 7x minus 5 over 12. What good at that? All right, beautiful.
Yeah.
All right, part B. Part B is a binary operation. What we call a binary operation, this one. So it defines a binary operation. Binary means operating on two values. It defines a binary operation star as A star B equals this. So you're adding the two values, squaring that result, and then subtracting twice the product. That's what star does. And asking us to work this out. 3 star 4 star 1. We have to do what is in the bracket first. Have to do what is in the bracket first. All right? So in the bracket, it's like the A is 3 and the B is 4. So we're doing this operation inside this bracket right now. All right? So inside the bracket, we're gonna get 3 plus 4 squared minus 2 times 3 times 4 inside the bracket. Star 1. Everybody understand that? What do we do that?
Yes, sir.
Good. I'm going to work out what value this is, and I'm going to star it to the 1 next. All right, so this becomes a 7 squared, which is 49, minus, this becomes a 6 times 4, which is 24, don't it?
Yes, sir.
Yes, sir.
Star 1. 49 minus 24 is 25. So it becomes 25 star 1. So the thing in the bracket works out to be 25. If you wanted, you could have worked it out by itself on the side, right? So we're now doing 25 star 1. So we're doing this same operation with the 25 star 1. So like the A is now 25 and the B is 1. So it now becomes equal to the sum of them first, which is 25 plus 1 squared minus 2 times the product of them. 25 times 1. 25 times 1. It becomes 26 squared minus this becomes a 50. What is 26 squared? All right, let's tell me what this work out. 26 squared minus 50 is how much? How much?
626, sir.
626 is the answer. 626. But okay with that?
Yes,
Nice
sir.
and easy. Nice and easy. All right. Now we'll come to this factorization. All right. That's what we're doing next, a factorization. So the first thing, okay, you have to work out what the star does now. You have to do the second star. You just like this is what they gave you, to do, this. They gave us this to do. They want us to work out the final value of this. All right? It's just that, just like in the order of operation, you have to work out what is in the bracket first. So the 3 star 4 works out to be 25. Works out to be 25. So you know how to do the 25 star 1. You understand? So this thing becomes 25 star 1 because this in the bracket becomes 25. And then you know how to work out the 25 star 1. So in this case now, this is like the A and this is not like the B. You have to work out what that is again. Understand? I'll finish it. All right. All right, let's do that next question now, part C. So part C first, it gives us xy cubed plus x squared y to factorize. So we go for the highest common factor. So if you look at the x values, highest common factor is the x. If you look at the y values, highest common factor is a y. So the highest common factor overall is xy. So like you're dividing xy out of each of these. Out of this, the x gone out here already. And out of this y cube, you take out a y, you're left with y squared in the bracket. And out of here, out of the x squared, you take out the x, you're going to have x left. And the y is already factored out here. So that is the result. And this inside, you cannot factorize any further. So that is it. But I go to that. All right. Second part now. Once it's the 4 terms, you know, the factorization by parts or by grouping. All right. So we have 2mh minus 2nh minus 3mk plus 3nk. 4 terms, factorization by parts. So you're going to check if the values are in a friendly order. So if we got these 2 first terms, the common factor would be the 2h. So you'd have m followed by n in the bracket. You'd have m followed by n in the bracket. So you check if the m and the n is at same order from those 2 terms, which they are. See? The m followed by the n. And so the values are already in a friendly order for factorization by parts, so you can proceed. Highest common factor in the first 2 terms, as we said, is 2h. Out of this, it leaves us with a m. Out of this, it leaves us with a negative n. I'll put by the m minus n over here. And then from this, you have factored in the m. So you must have factored out the minus 3k. Minus 3k was factored out. And then you can just check if it is correct by expanding. The 3 minus 3k times m going to give us this. The minus 3k times the minus n is going to be a plus 3nk. So that is factorized correctly. So then now the m minus n is a common factor for the next line. So you're putting these 2 together with that common factor. All right. And so this becomes 2h minus 3k times the common factor of m minus n. And that is it. Factorized completely. Very good? Online, very good?
Yes, sir.
All right. So we did a question like this next. The next one is an inequality, this one. So we did one like it the other day. Remember, to solve a simple linear inequality like this, this is the same steps as if this was an equal sign. 5x minus 2x equals 9. You're really trying to make the x a subject. The only difference with this one, because an inequality, is that if you have to multiply or divide the negative number, you have to remember to reverse that inequality sign, that less than sign. But the same steps that you would use to solve the equation, we're trying to make this x a subject. So the first step would be to get rid of this 5. Subtract the 5 over here. So you're going to subtract 5 from both sides. We have not multiplied or divided by a negative number, so the sign stays the same. When this 5 gone over here, we're left with minus 2x less than the 9 minus this 5 becomes a 4. Then we divide by this negative 2 to leave the x as a subject. Look how we're dividing now, see, divide by -2. So this time, look how we're dividing with a negative number, we have to reverse that less than sign. And so the inequality here becomes x. When I divide this by the -2, this sign is reversed to greater than. Then this 4 divided by the -2 gives me -2. So that says that x is greater than -2. That's a solution. All right, for part 1. Part 2 says if x is an integer, determine the smallest value of x. That satisfies the inequality. So if x was an integer, what are integers? Positive or negative whole numbers. So the integers x would be x equal, you cannot include -2 because you have to be greater than -2. To start at -1, then 0, then 1, then 2, then 3, and so on, forever and ever, amen. And that will be it. If you want to show the number line for this to make it more glaring, it would be like that, where your critical values are -2, then -1, then 0, 1, 2, 3, and so on. So you put the circle in the -1, because that's where you're starting. That's the boundary value. It's critical value. You want greater than it, and you put an unshaded circle because there's no equal on the inequality. Meaning the -2 is not included. Put the arrow pointing to the right. So the equal to be x greater than -2. So the -2 is not included down here. So the smallest value is this one, the first one. This is the smallest value. All right. So the smallest integer is x equal to -1. Smallest integer is -1. Gotta go to that online. No issues. All right, beautiful. So next one was a variations question. All right. I think I gave a inverse variation the last one. This one was a direct. With x and y. So the table below shows corresponding values of variables x and y, where y varies directly as x. So it's y and x are the variables. It's a direct variation. A direct variation means that the y is equal to a constant of variation times x. If it was inverse, it would be k over x for inverse, but this one is direct, so it's k times x. And the method we tend to use is the one where we find the k values first, and we always use a known pair of values, which they must give you. A known pair of values to find k. All right, remember it can be done without finding k, but let's practice how we find k. Because sometimes they'll ask you for the key. All right, you have to use the known pair of values. So this is the equation without knowing the key. So we're gonna say find key first. At x equals 2, y equals 12. That's a known pair of values over here. You plug these values in this formula to find the key. So therefore, the 12, which is the y value here, is equal to k times the x value right here, which is 2. You divide by this 2, you get k equals 6. Know that the k equals 6 is a constant, you can take it and put it right there. Hello. You can go back outside and talk, you know. Stop talking, man. All right. I'm coming out here, the place quiet, and come disturb the peace and quiet of the room. So we're talking, man, talk too much. All right. So the equation now becomes with the known value of k is a constant, it's not gonna change. Y equals 6x. So this is the formula now that will govern everything you do going forward, because you now know it fully. Remember now, we can do the question without actually finding the k, the 6, right? It can be done that way. We're going to use this now on these pairs to find out what the A and what the B is. On the first pair, the X is 5 and the Y is A. We're going to plug them in the formula. The X is 5 and the Y is A. You can stay quiet, please. You can stay quiet, please. They plug them in the formula. So the A is Y, or Y is A. So we can say, therefore, the Y value is A at that point is equal to 6 times the X value is 5. That's 30. So the A equals 30, as simple as that. You're going to use the same formula on the second pair, where the X is equal to B and the Y is equal to 48. So you plug these values in the formula here again. So you can say, therefore, 48, which is the Y value, becomes 6 times the X value. X value is a B. B. Divided by the 6, you get the B equals 48 divided by 6, which is 8. So the B is equal to 8. As easy as that. I think sometime I'm going to practice without finding the key and show you. I don't need to find the key. All right? You don't need to find the key. All right. That is it, guys. That is it. 3 down. We're going to do 2 more. More months equals. What time is it? 6:19 now. Start after 5 o'clock. Let's go. Next question. Next question. We're going to do this one. This one easy. We're going to do this one and send 2 questions in the group. And do them Thursday. Well, don't come to class just to go back home. You don't come to class to learn something. You don't know how to learn nothing, you know. Let's go. All right. This question says, a straight line passes through these 2 points. A, which is 1, 1, and B is 5, -2. E is a coordinate geometry question. First part wants the gradient of a line. Gradient of AB, small m for gradient. Is the difference in y over difference in x. Rise over run. Remember, the differential, the direction you go for the difference in y, you must go the same direction for the difference in x. So doing the B point minus the A point. So -2 minus 1. The difference in y, let me write it out. The difference in y over the difference in x. The only important thing is that the difference must be taken in the same direction. So it becomes equal to this y value minus this y value. -2 is this y value minus this y value is 1. Divided by the difference in x now. This x value minus this x value. That is 5 minus 1. This reduces to -3/4. -3/4 is a gradient of that line. Next part wants the equation, the gradient. Write down the gradient. Write down the gradient of any line perpendicular to AB. So I want a perpendicular gradient. Part 2. Perpendicular lines have negative reciprocal gradient. So if you have one gradient already and want to find the next one, the quick way to do it is to flip the one that you have and change the sign. Flip it and change the sign. So the perpendicular gradient, look at the perpendicular symbol here, is -1 over the gradient of AB. That's the relationship between perpendicular lines, or the perpendicular gradient is -1. So this calculation can be done quickly by flipping this one and changing the sign. So then it becomes 4/3. That is it. But if you flip this and change the sign, it's going to become 4/3. As easy as that. For calculation to be -1/-3/4, if you calculate it, but you put the gradient under here, this gradient you put under here, and we work this out, it's going to become that anyway. All right. But the quick way to do it is flip the gradient that you have, change the sign. So this is the perpendicular gradient. Any line perpendicular AB will have this gradient. Next part now says, part 3 said, determine the equation of a line which passes through that point and is perpendicular to AB. I must write the equation in the form y equals mx plus c. Easy. So in part 3, you want a line, you want a perpendicular line. To AB. So to find the equation of any line, you need to know two things about it. You need to know the gradient, which we know the gradient is the perpendicular gradient, and a point. The point that I gave us is this point D. So the gradient of the line that we want is the perpendicular gradient, which is the what? 4/3 we said? Yes, 4/3. And it passes through the point D, which is 3/2. Using this gradient and this point to get the equation. The equation of that line using the point gradient form, which I call the BFF, is y minus yd equals the perpendicular gradient into x minus xd. But D is the point. So it's y minus the y by the point D is 2 equals the perpendicular gradient to say is 4/3 into x minus the x by the point D is this 3 right here. So now because we're going to expand this on this bracket, this times this is going to give me a whole number. I'm just going to expand it straight across. So it's going to become y minus 2 equals the 4/3 times x is 4/3x. 4/3 times minus 3, the 3 cancel and give me -4. Then this -2 comes over and becomes a +2. And so the equation becomes y equals 4/3x minus 2. And that is in the form y equals mx plus c, right? That is it. So that is the answer right there. Quick and fast. Now, see, we can do another question. Get done already. One more. Still I go home early today. Don't cry. But good. Online, about good.
Yes, sir.
6 minutes. It's just 1 hour class and I get then. That wouldn't another question. More math equals better math. All right, let's just do this linear programming. And we'll call it a day. I'm not going to pressure you because I want it to be. I want to give you full attention. All right, let's do the linear programming. Call it a day. All right, this question says, a farmer supplies his neighbors with X pumpkins and Y melons. With a 1 L spelling of that melons. All right, don't matter. So it's X pumpkins and Y melons. So X is the number of pumpkins, Y is the number of melons. You don't know X and you don't know Y. And they are sold under these conditions. The first condition is this. The second condition is that. And the third condition they give us in words. It says we have to write the inequality of the third one. Write the inequality to represent the third condition. That's this one. See? The opinion. What does this one mean? If you ask you to say this one in words, what would you say? First one. Y is greater than 3. What would you say? Y is greater than or equal to 3. What would you say for the first one?
Yeah.
If they told you to write this one in your own words, what would you say?
The amount of melons is greater.
Not amount.
Equal
Not
to.
amount. Not amount. You're counting. You're able to count. You do not use the word amount. Amount is for measurement. So start again. The word amount is used for measurement. You have to measure something. When you're counting something, when it's something that you can count, you say the number of something. You can count it. Start again. Online. Come on. Let me hear you again.
The total number of pumpkin melons should be greater than or equal to 3.
All right. So he said the number of melons must be greater than or equal to 3, which is true. Which is true. But they might say there must be at least 3 melons, don't it? Don't it? Mean the same thing. There must be at least 3 melons. That is the way they would mostly write it in a question. There must be at least 3 melons. You must supply at least 3 melons. There must be at least 3 melons. Number of melons must be at least 3. We'll say that as well. The number of melons must be at least 3. All right, go to that. All right, go to turn, Mr. Shaw. There must be at least 3 melons. This one now. Interpret this one for me in words, in your own words. Somebody from my class, somebody online said it a while ago. Come on, tell me second one. How would you, the architect say that one in words? What would you say?
That
Huh? Let's read it straight. Let's read it straight. What is y? What is y?
equal or less than X.
No, man. You have to say it in terms of the melons and the pumpkins. If you're interpreting this, you can't read it down say y and x. You have to use it in terms of what they represent. Y is the number of melons and x is the number of pumpkins. So your statement must say that.
Melon equal or less than pumpkin.
Can't say melons. Y is not melons. Y is not melons. Y is not melons. Y is the number of melons, a difference. And X is not pumpkins. X is the number of pumpkins. Good. All right. May I make sure I drive it home? Because some people say melons. Melons must be less than pumpkin. No. The number of melons. Because you can't say melons. What about the melons? It can be the weight of the melons, you know. If you just say melons, what about the melons? If somebody just say melons must be less than pumpkins, what about the melons? Can be weight, can be color, can be whatever. So you cannot just say melons. You get me? The number of melons must be less than or equal to the number of pumpkins. Spell it out. X is the number of pumpkins. Y is the number of melons. Use those words. Number of. That's what X and Y represent. The number of the various items. Of the two things, right? So this one is that the number of melons must be less than or equal to the number of pumpkins. All right? They don't say melons. The number of melons, which is the Y, must be less than or equal to the number of pumpkins. Somebody tell me another nice way you could say it. Could say the number of, yeah, go on, let me hear online.
What you say what other, sir?
Tell me another nice way you could say it.
Number 2.
Oh, yeah, this one, yeah, number 2. Tell me another nice way somebody could say it to somebody. In actual conversation, some two persons talking and talking about the number of millions and the number of pumpkins, yes? All right, so let me ask you something. If you go downtown and you buy some pumpkin and some melon, you go say all of that to the person where you buy it from? How would you say it to the person you're buying it from? That is the question. How would you actually say it in real life? Because that's what mathematics is, and mathematics is how would you do something in real life? How would somebody go in a store and buying some melon and pumpkin and talk to the person over there? And what do you think they would have said to the person? They would have said something like the number of melons can't be more than the number of pumpkins and something like that. The number of melons can't be more. The number of melons cannot be more. I don't want the number of melons to be more than the number of pumpkins. It means that it can be equal to the amount or less. I don't want the number of melons to be more. I don't want the melons to be more than the pumpkin. Yeah, ma'am? I don't want the melons. I don't want the number of melons to be more than the number of pumpkins. That's what they might say, something like that. Meaning, they don't want more melon at the bag. They can put them equal or less. You don't want the number of melons to be more than the number of pumpkins. So the number of melons must be less than or equal to the number of pumpkins. Sure. But how would somebody say it in real life, talking in English language to each other? That's something like that they might say. Downtown, they're not talking at the shop or in the store or wherever in the supermarket. And I'll give an order. Don't make the number of melons more than the number of pumpkins, man. I don't want more. Can make them equal, but don't make it more. Don't make it more. I don't want the number of melons to be more than the number of pumpkins. The number of melons must be no more than the number of pumpkins. That must not be more. It can be equal. By saying that it can't be more, you're basically saying, okay, it can be equal or less. It can't be more. There must be no more. The number of melons must be no more than the number of pumpkins. That must not be more than. You get me? All right. No problem. All right. Next one now. I want us to write inequality for this one. It says the total number of melons and pumpkins must not exceed 12. Must not exceed 12. What that mean now? What you write inequality for this one? Inequality for this one here now. I'm circling in blue. What's inequality for that one? The total number of pumpkins and melons must not exceed 12. 1 dozen. So that's what might say must not exceed 1 dozen. I don't want no more than 1 dozen fruits in my bag, lady. I don't want buy some melons and some pumpkin. What is melon? Is fruits that? Melon and pumpkin are fruits? Are fruits? Melon and pumpkin, they are fruits? They're what? All right, let's just call them provision. Let's just call them provision. All right, let's just call them provision for want of another. All right, downtown now, we're talking. Hey. So then go down to the talk and talk to the lady. I want some pumpkin, I want some melon, Miss D. I don't want no more than a dozen. Put them in there, I don't want no more than a dozen. The bag can only hold 1 dozen. Don't put no more than a dozen, please. You see that? Something like that. They don't want no more than a dozen. See at most they want a dozen. A dozen is 12. So the total must be no more than 12, right? So how would you write inequality for this one now? Talk to me. Less than or equal to 12. Good. So that is it. All right. So see, that's what this is. Next part now says, using a scale of 1 centimeter represent 1 pumpkin on the x-axis, 1 centimeter represent 1 melon on the y-axis. Draw the graph of 3 lines associated with 3 inequalities. All right? They want us to draw the graph. So let's remind ourselves of these things. Sorry. Couldn't hold that one. Couldn't hold it. All right, let's go. The first one was y greater than or equal to 3. Second one was y less than or equal to x. Let's remind ourselves of what we consider to draw the graph. Remember, inequality on a graph is really and truly about the region that is either above or below a line. Generally speaking, greater than means you want above the line, less than means below. But the caveat is that the y must be on the left side of the inequality for greater than to mean above and for less than to mean below. We have a problem here because the y over here is positive, the y over here is positive, the y over here is positive. So this greater than means above, this less than means below, this less than means below. Then now the line is either drawn broken or solid. Solid line means that the line is a part of the inequality, means that points on the line are also valid. A broken line is when points on the line are not valid, and that is indicated when the equal is not a part of the inequality. So for example, if this third one, the equal was not there, then you'd have to draw this line associated with that inequality broken. So you don't only want the region below the line. You would not want points on the line. Points on the line would not be valid if this was the case. All right, but you don't have that here now, so you don't have a problem, right? So that's why I thought what each one means. It's with respect to what you're going to put on the graph. This is what you don't need to do, but this is what you need to be considering. So this first one means that you want above the line. The line is going to be drawn solid because of the equal. So the line is a part of the inequality. It's going to be drawn a solid line, an unbroken line. And the line you're drawing is the one associated with this inequality. That line is y equals 3. Y equals 3 is the line associated with that. Y equals 3 is a horizontal line passing through 3. If you don't remember, whether that horizontal or vertical, remember that the x-axis is the line y equals 0. So y equals 3 must be horizontal like the x-axis. All right? Let's remember these things. Hey, you know, somebody will tell you don't come into my class and don't come back. No, because you're laughing. Okay, man, about that foolishness. And don't get me upset. All right, then this one here now. The y is positive, so less than means below. Below. Remember, when the y on the left side of inequality is positive, less than means below. The line again is drawn solid. But the equal is a part of inequality, means that the lines are part of the inequality. And the line is drawn is y equals x. That line is an easy line. Passes through points where the x and the y value is the same. Points like 0, 0, and 6, 6. Pass through points like those. Then this third one now, the less than means below because the y over here is positive. When the y on the left side of the inequality is positive, less than means below. The line again is drawn solid. This one is going to be drawn solid because of the equal. And the line associated with this inequality is simply x plus y equals 12. And that's one of the easy lines to draw, x plus y line. It crosses the x-axis and the y-axis at this same number, 12. So it passes through 0, 12 on the y-axis, and it passes through 12, 0 on the x-axis. One of those easy lines to draw. So none of these have to be calculated in the coordinate. Let's just sketch it all quickly, quick and fast. Quick and fast. Y-axis, x-axis. 1 centimeter to 1 unit. I'm going up to 12. 2, 4, 6, 8. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. X-axis, y-axis now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, let's draw the graphs in purple now. The first one was y equals 3, and it's a horizontal line passing through 3. The 3 right here, so we need a horizontal line passing through. This is it. Label the line with the equal sign. That's the line y equals 3, and you want above that line. Put arrow pointing up to show that you want above the line. So the region I want is somewhere up here. The next line was y equals x. And we're going below that line, y equals x. So that line, it passes through 0, 0. It passes through 3, 3 right here on this line. It passes through 6, 6, and so on. So I'm going to just draw it up like that. Bam. Label the line with the equal sign. This line is y equals x. So it's supposed to pass through 12, 12. Not to scale, but it's all right. We work with it. All right? Are not so accurate. The next line we're drawing is the x plus y equals 12. Passes through 0, 12 on the y-axis. Passes through 12, 0 on the x-axis. Passes through these 2 points. The line x plus y equals 12. This one. X plus y equals 12. And also passes through 6, 6. And passes through 9, 9, 3. Passes through points where the x plus y equals 12. That's it. When I label the line with the equal sign. Label the line with the equal sign. X plus y equals 12. And we're going where? Above that line, above that line, below that line, below this line. Below this line. All right, so the region that we want is above this line, below this line, and below this line. So this is the region in this triangle right here. Common region that satisfies all inequalities. All right, so that is it. So draw the graph, and it said identify by a shading region that satisfies the inequality. So we'll finish that part. Next part now says determine from your graph. Determine from your graph the minimum values of x and y that satisfy the conditions. Tell me from the graph where the minimum values would be that satisfy the conditions. Where? Huh? Right at this vertex right here. Minimum value of x and y is at that vertex. 3, 3. So the minimum value of x and y that satisfy the conditions will be 3 and 3. So the answer for this is x equals 3, y equals 3. That's it. They don't want no profit or nothing in this one. So it's an easy one to do today. All right, guys. That's it for today. Don't bother the foolishness. You need to go and do the questions. I'm going to send a couple questions in the group. So this transformation question and this vectors question over here. I need to send at least 2 or 3 questions in the group. Bye, everybody. See you. Students online, you good?
Yes, sir.
Yes, sir.
All right. All right. See you tomorrow. So tomorrow is online for you guys here. And the students online should come face to face tomorrow. Yeah. All right. Bye, everybody. I'm gonna end it now. And I'll send it to the group.
Bye, sir.
All right. Bye-bye.